In this video, I'll be working through the question you see on the screen here from the Maths Paper 1-3 from 2024 Cambridge A-Level exams. If you're looking for a different question from this paper, have a look in the description below. There should be a link to a playlist. And if you're looking for a different paper entirely, have a search on my channel. I'll be doing all this on a whiteboard, hopefully just like you're used to doing in the classroom. But remember, we're not in the classroom, we're on YouTube, so take advantage of that. Pause, rewind, even watch it at a different speed. If you find this video or any of my videos useful, I would greatly appreciate a like, a subscribe, a share, or even a super thanks.
In question 9, we're given this picture here with this area shaded in. So they're going to ask us something about that area, but not in part A. So that's a little bit of a misdirect. That's mostly this picture is for part B. Although in part A, they do ask us to find the equation of the tangent to this curve at this point here. So basically the equation of this line, something like that. They tell us the curve is this, and they tell us y equals 3 at that point. Yeah, that's pretty much it. They want the equation to look a certain way. We'll deal with that later. Okay, how do you find the equation of a tangent? We did this just in the last part as well, although we didn't use differentiation. You should be thinking slope and a point. So we need this point and we need a slope. Let's get slope first. Slope, you should be thinking derivative. dy dx gives you the slope. So what's the y dx of this? First let's write y again. 2x cubed plus 10 to the power of a half. I'd much rather write it that way, so hopefully you're on board with that. So how do we differentiate this? We sort of use substitution in here, and that uses the chain rule. But I'm going to assume you're A-level students. I'm going to assume you can do this a little faster using the chain rule. We think of in here as one solid object, and we differentiate. So it's a half multiplied by this to the power of 1 less. So it's a half multiplied by whatever this was, 1 less than this, that's a minus a half. And then we multiply that by the derivative of whatever we covered up. So the derivative of this. That's 3 times 2 is 6. X, take 1 away from this power, that's x squared. And this is 0. So that's the chain rule differentiating this. We can clean this up. This half and this 6 go together to get 3. So the top row here would be 3x squared. Remember, this minus tells us we're on the bottom row. 2x cubed, plus 10 to the power of a half, or square root if you rather. Okay, that's the derivative. We're interested in the derivative. We're interested in the derivative when x equals 3. When x equals 3. So we just write this out, but instead of x we put a 3 in. So that's 3 times 3 squared over 2 times 3 to the cubed, 3 cubed, plus 10 to the power of a half. What's that? That's 27 on the top. That's 27 times 2, that's 54. 54 plus 10, and that's the square root of that. That's 27 divided by 60. The square root of 64 is 8. Okay, that's the derivative at this point. That means that's the slope. That's the slope of the thing we're interested in here. So how do we find the equation of a line? We need the slope and we need a point. And that's where students often go, wait, what's the point again? What is this point here? It's 3 something. So you could have done this first as well. We need to know what y equals right here. So y is right here though. Y equals the square root of 2 times x cubed. We know x is 3 cubed plus 10. We just did that in here. That's 54 plus 10. That's y equals 8. So this point here is 3, 8. So what's the equation? Well, the equation is just y is equal to the slope, 27 over 8 times x, plus c. To find c, we just fill in the two numbers we know. We know y, we know x. So that's 8 is equal to 27 over 8 x plus, oh sorry, not x, times 3 plus c. Multiply everyone by 8. Let's stay going over here. Multiply everyone here by 8. We get 64 is equal 3 27s is 81. The 8 cancelled there. Plus 8 C's. Rearrange this, we get 8C is equal to minus 17. C is equal minus 17 over 8. And we fill that back in to this line. We get Y is equal 27 over 8 X minus 17 over 8. Okay, that's nearly full marks. That is the equation they're looking for. It's just not in the form they're looking for. They wanted, I can squeeze it in up here. They wanted X, then Y, then a number equals 0. So let's just move everyone over to right. 27 over 8 X minus Y minus 17 over 8 equals 0. That's sort of what they want. They wanted the X, the Y, and the C. Except you'll still lose a mark. They wanted integers. They don't want fractions. So we better multiply everyone by 8 to get rid of that. So 27x minus 8y minus 17 equals 0. That's what they were looking for. In part B, I said they were going to ask us about the area of this. I was wrong. They actually asked us about the volume of this when we rotate it around the x-axis. So it's a common enough question. It's a weird question. I love it visually as an idea. We have to think three-dimensionally. But you imagine this shape being rotated around. The best way to think about it is just one line being rotated out. Let's flip the world on its side and we'll visualize that as a circle appearing. We're rotating it out of the board and back in. That circle has a radius or a radius y. The height of this line is y. So the area of this circle would be, instead of or, be y. It's pi r squared. Pi y squared. That's the area of this circle. And integration, what it does is it does one of them, 2, 3, 4, 5. It does lots of these circles in a row. It does infinite number of them and adds them all together. So all you have to remember is the equation that the volume is equal to pi. That's from the circle. The integral of y squared dx. So just what that means is that's the radius. That's the radius of all these little circles. Pi r squared. That's all it is. And the integral just means we're going to add loads of them together. Once you remember this equation, you should be fine. So that's all we need to do. We need to do this between 1 and 3. So we can just fill this in. It actually works out very nicely. It's pi, the integral of what's y squared? Well, y is a square root, so it's just 2x cubed plus 10 all over the change in x. We can integrate that. The integral of this is 1 more to this number, so we get x to the power 4. And then we divide what's in front here by that new number 4, so that's 2 over 4. The integral of 10 is 10x. And there was a pi out front, wasn't there? And we're going to evaluate this between 1 and 3. That goes in just a half. If we put 3 in here, 3 to the power 4 is 9 squared, which is 81. So that becomes 81 over 2. Plus put a 3 in here, we get 30. Take away putting a 1 in. So 1 goes in, we get 1 over 2. That's a half, and we take it away. We put 1 in here, we get 10, but we take it away. And all of this is multiplied by pi. You can do this in calculator, of course, but 81 minus 1 half, 81 halves minus 1 half is 80 halves. 80 divided by 2 is 40. So this just becomes 40 plus 30 minus 10. That's a 70 minus 10, 60 pies. And that's the answer. That's the area of that weird shape. I won't try and draw it. I tried that in a different video, which I don't think it looked that good. Okay, that's the answer to part B and all of question 9. If you have any follow-up questions, let me know in the comments. I'll do my best to get back to you. Thanks for watching. Have a great day.